Hello and welcome back to another video. This problem, first we're asked what is a one-to-one function and how can you tell if a function is one-to-one by looking at its graph. So a one-to-one function is a function for which every input has a unique output. This is different from just the standard definition of a function, which states that every input has one output. This is saying not only do they only have one output, but all of the different inputs have different outputs. How can you tell if a function is one-to-one by looking at its graph? The vertical line test. If every input the horizontal line test. The vertical line test is done for finding if it's a function at all. The horizontal line test is, let's say, putting a horizontal line between at any point in the xy plane. So I'll just come up with a graph here to explain it better. Here, let's say the pen represents the horizontal line. It can only intersect the function once for it to be one-to-one. If it intersects more than once, like up here, it intersects it more than one time, that means this input, and this input all have the same output. They're not unique, therefore it's not one-to-one. The vertical line test is just, is it a function? Is there for any input only one output? So that's why I messed them up. B, if f is a one-to-one function, how is the inverse defined? And how do you obtain the graph of the inverse from the graph of f? So f is a one-to-one function. Its inverse is defined as this. So if f of x equals y, then f inverse of y equals x. Right? You're basically just swapping the variables. So the output gets put into the function, and it puts out the input. You obtain the graph of the inverse from the graph of f by reflecting over y equals x. So for example, this is y equals x, and this is our function. The graph of the inverse is going to look something like that, right? It's reflected over this line.